Okay, do you need number 17?
No, I got 17
Okay, so you just need 19.
and
Okay,
18.
and 18. All right.
Because, like, I don't know what I'm doing wrong with 18.
Okay, from a boat on the lake, the angle of elevation to the top is 29 degrees. Okay, I hate the fact that she doesn't leave enough room. Okay, but, okay, never mind. Um, so that's 29 degrees and 1 minute. Okay.
Yeah.
If the base of the cliff is 155 feet from the boat, how high is the cliff? Sounds like a job for tangent. So, tangent, now we need 29 plus 1 over 60. Okay, equals opposite over adjacent. Is your calculator in degree mode?
Wait, hang on, I need to grab it. He's doing English, so give me a sec.
Okay.
Uh, it is now.
Oh, well, I think that might have been, I'm going to guess that might have been your problem.
Well, and I didn't know to do the 1 over 60 part.
Yeah, you got to
Like, how did you
change.
get the 1 over 60?
Yeah, you got to change that 1 minute to degrees.
Oh, okay.
Yeah, there you go. The light bulb's on now.
Yeah, because I was like, I'm not, because it says 86 is the answer, and I was like, I'm not getting 86.
Yeah. Okay, I'm gonna clear this out, and I mean, I'll post this video anyway so you can see it on YouTube. But I'm gonna clear that. Clear. All right, so let's see on the next one. Are you okay on 18? Can I move to 19?
Yeah, you're good.
All right, find the value of the unique real number between 0 and 2 pi. Okay, so they're telling me sine is positive. That's in quadrants 1 and 2. And the tangent is -1. So that means we are directly in the middle of quadrant 2. So they want the angle measurement that would give that between 0 and 2 pi. Now I'm going to switch over here to a different document for a second and show you a better looking picture. Okay? Just
Okay.
about. So we're directly in the middle of quadrant 2. Now, do you know your radian measure angles enough?
Um, I know that quadrant 1 around that point, like, flipped over, that's pi over 4,
Okay. What I want you
and
to what
that's
I want
pi
you
over
to
2.
do, and oh, I got to get rid of those annotations. They're driving me nuts. Clear all drive. Okay. Yeah. So notice that the picture that's in the middle of your screen is a circle that's based on pi over 4 increments. So what I've done is I've counted around the circle. There's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Do you see it?
Gotcha.
Okay.
Gotcha.
So the slope of this one, the one in the middle, is -1. Just like the slope of pi over 4 is +1.
Okay. Okay.
Now, do you understand why the slope is negative?
Yeah.
Okay. Yeah. So really, they want this answer, 3 pi over 4.
Okay. Okay.
That's what they're looking for in that question.
Gotcha. Gotcha.
So are we good on that particular problem?
Yeah, I'm good on 19.
All right, now let me go back and we'll find the next one, which was, is it this whole thing, 20 and 21?
Yeah, because like the wheels just messed me up and I don't know why.
Okay. Susie's on a merry-go-round which is spinning at 10 revolutions per minute. Okay, so annotate, come on, 10 revolutions per minute. If she is seated 20 meters from the center of the merry-go-round, what is her speed in meters per second? Okay. What is the circumference of that particular wheel? Of the merry-go-round? So 2 times pi times the radius, right?
Yeah.
So it's 40 pi meters per revolution. Okay?
Okay.
So we want to do the stuff we did in chemistry to convert this from revolutions per minute to meters per second. So for instance, 1 minute is 60 seconds, so that would get rid of my minute units.
Yeah.
So now I've got revolutions on the top, I got seconds on the bottom. I need seconds on the bottom because I want to get this into meters per second. So now I'm gonna use this thing over here, and since I want meters on the top, I want 40 pi meters over 1 revolution. So now the revolution units cancel. So now I have meters on the top and seconds on the bottom.
Okay.
So I can literally multiply straight across the top, straight across the bottom, and divide.
Okay. So that wait, do I keep it? Do I just do like the 10 times the 40? And
Yeah,
like
so you're gonna have
400.
400 pi over 60, and that's meters per second.
And am I supposed to simplify that?
Yeah, I'm sure.
Okay.
I'm sure that.
Gotcha.
How many meters does she travel in a 3-minute ride? Well, I think we should just multiply that by 180 seconds. Because that's 3 minutes.
Okay.
And whatever you get out of that is your answer. So this is my answer to part A. This would be my answer to part B. So this is a very similar type question, number 21. If he's got 18-inch diameter wheels, then he has, that would be 18 pi, that would be inches per revolution. Is that okay? Does that make sense?
Yeah.
Diameter times pi. If he's traveling at 50 miles per hour, okay, so 50 miles over 1 hour. How many revolutions per minute? So we got to get this all the way to revolutions per minute. Okay. So we want to convert it from miles to feet. So there's 5,280 feet in 1 mile. Did you know that fact?
Yeah, because 5 tomatoes.
Amen. Good call. Okay, so we got that taken care of. And then there's 1 foot is 12 inches. So now my feet units cancel. So now I've got inches on the top. That's good because I'm going to use this fact now. Okay, now be careful here. We want to use it because we want revolutions in the top. So when I use this fact, I'm going to put 1 revolution in the top and 18 pi inches in the bottom. So the inches units will cancel. You see how I flip that upside down?
Yeah.
Okay, now, right now we have it in revolutions per hour. I've got to get it to revolutions per minute, so I have one more fraction I need to multiply by, and I'm running out of room. So it would be what? 1 hour over 60 minutes. And then my hour units will cancel out. So now the only thing I have left is revolutions on the top and minutes on the bottom. So you got to multiply all that crap on the top, and on the bottom you got 18 pi and 60.
All right.
Does that make sense?
Yeah, that makes sense. It's just like when I read 21 at first, I start like drawing wheels, and then I get like messed up because I'm sitting here drawing circles.
Gotcha. Well, just understand that you gotta find the circumference, and the circumference is 1 revolution.
Okay.
That's one of the keys.
Gotcha.
All right, now I'm gonna clear this, and I need to go back and find the other picture. Oh, not that way. Okay, so it was this one here?
Yes.
Okay.
This one confuses me because, like, I remember doing this in whenever I learned this geometry or something like that,
Yeah.
but I don't remember like it won't come back to me now.
Okay, so you just have to pick which of these trig functions you want to use. Is it sine, cosine, or tangent?
I know it's like it just depends on which way I go.
Okay, so pick an angle. What do you want?
Let's just do 52.
Okay, so this would be the adjacent side to 52, and this would be the hypotenuse. So that looks like a job for cosine. Now don't shoot the messenger, right? Because this is adjacent over hypotenuse. Now remember, this is a proportion. How do we handle proportions?
Butterfly.
Yeah, the butterfly. So 1 times 1, and then I divide by the cosine of 52. Making sure my calculator is in what mode?
Degree, right?
Degree mode.
Yeah, okay. Wait, I'm gonna check and be sure. Okay, yeah. Maybe that's what I was doing wrong.
I'm gonna guess.
I thought I was doing it right.
Yeah, I'm gonna guess that was probably your issue.
I'm gonna do this really quick and see if I get the right answer. Yep, it was in the wrong mode.
All right.
That's gonna kill me tomorrow.
More than likely. Okay, listen to me. Every triangle question where you have to find a side or an angle, she's never going to put, or your teacher is never going to put degrees in a triangle. Or I mean radians in a triangle. They're always going to be degrees. Now, the only time we draw triangles and we look at radians is typically when we're talking about the unit circle. I don't need my calculator for the unit circle. I'm looking at it and it's either 1/2, radical 2 over 2, radical 3 over 2, or 1. Or my slopes, radical 3, 1, or radical 3 over 3. So I don't need a calculator for the radian stuff. We haven't done anything that needed a calculator for radians. I mean, yes, you can ask me to use my calculator and switch it to radian mode, and I can do the cosine of 7 pi over 8, which is not one of the normal angles we work with. But I doubt she's going to ask you that. I have a feeling you're going to be dealing with triangles, and they're all going to be in degree mode. So I bet you can leave your calculator in degree mode The other thing I have seen kids do in the past is they do every question on a quiz or test that involves triangles in degree. Then they switch their calculator to radian mode, and then they go back and do all the other questions.
Gotcha.
So I'm like, you could do that. I mean, or you could bring two calculators. You know, a scientific one that's in degree mode, and a graphing calculator which is in radian mode. I've seen that done too.
Yeah.
So
I don't know. We'll see how it goes. I mean, I'm like 50-50 about it. Like, I know the stuff, like, okay, like how to, where it says, I have a question on here. It says, find the exact values of the indicated trigonomic functions, write the functions in, or fractions in lowest term. Like, that's easy. I can do that stuff. But it just, like, I don't know. We'll see how it goes.
there's a lot of stuff in that section, in these first three sections.
Yeah. And it's like review too, and that's the thing that I'm like tripping up about because I can't remember any of it.
Well, it was at the end of the year last year, and most of you were in shutdown mode before final exams. So, not much stuck. I mean, to be truthful, you guys are burned out at the end of the year, and you want to be done. So, it's hard to get things to stick in your brains. So, okay, I will be in my room tomorrow morning if you have any more questions, and I will get this video posted for you on YouTube.
Okay, thanks, Daly.
All right, talk to you later.
See ya.
Bye.
Bye.